Good afternoon. Good afternoon. Hope everyone's doing all right. Everybody's well. We'll give everybody a chance to get in here and then we will get started. All right. So, once again, hope everybody's doing great. Everybody's all right. For those who may have missed it, we didn't have class Monday because of the inclement weather. TCC had actually closed down campuses and all online activity. So last week we closed out with 5.1. We're going to do 5.2 today. Only going to do 5.2 because in my last class, we only did 5.2 because I had a dentist appointment that I had to get to. So I try to keep my classes, at least both of you guys' classes, in the same place. So we only do 5.2 today. And 5.2 starts with the properties of normal distribution. So it starts with the empirical rule. Now your book doesn't even call it the empirical rule. They call it the 68, 95, 99.7 rule. So they're the same thing. To me, the empirical rule is shorter to say. But yeah, your book references that the 68, 95, 99.7 rule. And so basically it says approximately 68% of the data is within one standard deviation of the mean. So I did SD as short for standard deviation. Approximately 95% of your data is within two standard deviations of the mean. And 99.7% of the data is within three standard deviations of the mean. And so they also said more precisely, instead of 68, it's actually 68.3. And instead of 95, it's 95.4. But that's if you're being, real precise. But normally those two values in red don't come up. It's a 68, 95, and 99.7. I'll give you a chance to copy that down. And we're going to talk more about what this actually means in a second, but just give you a chance to write it down. All right, scrolling up. Before we get into the diagram, just re-emphasizing the notation. X is going to be our data value. You'll see when we get into z-scores what I mean by that. But your mean is going to be Greek letter mu. And then the little circle with the extension to the right is going to be your standard deviation. So that's the symbols we'll use for that. And that's Greek letter sigma. Now that's lowercase sigma. You may have seen capital sigma, in Greek letter fraternities and stuff like that. What the capital sigma actually means summation. In other words, adding up all of your data values. But the main ones we're looking at are these three over here. Just a regular X is going to be your data value. Mu, Greek letter mu, is going to be a mean. And then sigma is your standard deviation. So here's the diagram that illustrates those three statements from the empirical rule. We have our mean in the middle, and everything to the right of the mean reflects what's going on to the left of the mean. Remember, we talked about normal distribution before, symmetric, bell-shaped curve. So 50% of your data is to the right, 50% of your data is to the left. So these percentages add up to 50% on the right, and then 50% on your left, which gives you a full 100%. These percentages do not change. That's the empirical rule. The values down bottom will change according to the information that you're given. You'll see it when we get to an example. But once again, these percentages do not change. And so you see going out one standard deviation, 34 and 34 gives you that 68%. If you go out two standard deviations, add those four together, that gives you 95%. And then if you were to go out three standard deviations, that's your 99.7%. And then you notice 0.15 is on the ends, and that's going to add up to that 100%. I'll give you a chance to write that down, and then we'll look at an example that further explains it. All right, anybody still copying? Let's scroll up. And so when we get to this next example, I didn't mention this, we have our mean in the middle. And to get these three values over here, all we're doing is adding the standard deviation 3 times. To get the values to the left, we're just subtracting the standard deviation 3 times. And so that's what we're going to show in this next example. So we have the mean IQ score of students enrolled in University A is 100, and the standard deviation is 16.1. Determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. Determine the percentage of students who have scores between 67.8 and 132.2. And then determine the percentage of students who have scores above 132.2. So I'll give you a chance to copy it down for those who are copying it, and then we'll walk through it. All right, let's scroll up. All right, so the given information is just that our mean is 100, standard deviation is 16.1. So remember, we have our mean, and then we have the right side of our mean, left side of our mean, as far as calculating the data values that go at the bottom of our empirical chart. So we talk about to the right side of the empirical rule, not the empirical rule, of your mean. All you're gonna do is add the standard deviation 3 different times. So adding it once gives you 116.1. Adding the second time, that's 132.2. And then the third time is 148.3. And that represents the 3 standard deviations above the mean. All right. And then to find the left side, we're going to subtract the standard deviation 3 times. And that gives us these 3 values: 83.9, 67.8, 51.7. So you have your mean in the middle, add the standard deviation 3 times to the mean, get these 3 values. Your mean is in the middle, then you're going to subtract the standard deviation 3 times to get these 3 values. And that represents the 3 standard deviations below the mean. All right, so here's our diagram. Once again, I told you those percentages, they stay the same, but the numbers down bottom is what will change according to the information that we have, whatever our mean and our standard deviation would be. So we have our mean in the middle. Then to the right are those values that we added, standard deviation 3 times, and then to the left are the values that we subtracted the standard deviation 3 times. So before we go any further, questions on what we did here or how we got there? All right, are we ready to go answer those questions? All right, so the first question: determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So now we didn't need to fill out this chart in order to answer that question. It says according to the empirical rule, within 3 standard deviations is going to be 99.7% of the data. So that was just based on the empirical rule. And that's why that answer is just 99.7%. Now with B, determine percentage of students who have scores between 67.8 and 132.2. So 67.8 is right here. 132.2 is right here. So what you would do is take the percentages between, because that's what he mentioned, between those 2 values and add them together. So that ended up being 95%. Any problems with that? And then C, determine the percentage of students who have scores above 132.2. 132.2 is right here. These are values above 132.2. So we add those two together and that gives you 2.5%. Questions, any questions? All right, can I scroll up? All right, so the next thing in the section are your Z-scores, also called standard score. Is the distance a data value is from the mean in terms of the standard deviations. So here's the formula to calculate your Z-score or to convert your data value to a Z-score. So it's your data value minus the mean divided by the standard deviation. Just a way that we can, so Z-scores are a way that we can compare data values that belong to different groups of information. So you'll see an example of that in a second. Just want to give you a chance to write that out. All right, scrolling up. A couple statements about Z-scores. I know in our old math lab shell, that was another book though, that had questions about this, but just in case, Z-score is unitless and it has a mean of 0, standard deviation of 1. That's going to more so come into play when we get to our Z-score chart, which is in another chapter altogether, but you'll see that the mean is going to be 0 once you do your conversion and all the good stuff like that. But came up before, so just in case it comes up again. Scrolling up. All right, so it says determine whether the Angels or Rockies had a relatively better run producing season. The Angels scored 773 runs and played in the American League, where the mean was 677.4 and standard deviation was 51.7. The Rockies scored 755 runs and played in the National League, where the mean was 640, and standard deviation was 55.9. Give me a chance to write it down. All right. So the reason why this is neat to do is because we have two different baseball teams, and even though they both play in the American League, I mean the Major League Baseball, one plays in the American League, one plays in the National League. If you know anything about baseball, American League and the National League have, or at least they had, I don't know, we got different rules now, but had different rules going on in the different leagues. And minor rules, but it still affect things. So comparing the two leagues and then comparing two different teams in the different leagues, would matter to some degree. So that's why you have one that has a different average versus the other one. So let's look at our given piece of information. Angels had runs of 773. That's the data value in question. The mean of the American League was 677.4, standard deviation 51.7. Rockies 755, mean of the National League 640, and standard deviation 55.9. So now we're going to convert both to z-scores. So do your data value minus the mean divided by the standard deviation. So 773 minus 677.4 divided by 51.7. That's 1.85. And then 755 minus 640 divided by 55.9 is 2.06. And so you get in the habit of rounding your z-scores to 2 decimal places. Now, notice in your book, it said 1 or 2 decimal places. So just make sure you're paying attention to what MATLAB is asking of you. But I know when we go to our z-score chart, once again, that's not in this chapter, but once we get to our z-score chart, we will be rounding to 2 decimal places. So. All right, scrolling up. So coming to our conclusions. The Angels scored 1.85 standard deviations above the mean. So it's above the mean because the z-score was positive. If it was negative, then we would say below the mean. And then the Rockies scored 2.06 standard deviations above the mean. So this means that the Rockies had a better run producing year. All right, questions. Let's do another one. course, if I scroll up too far, let me know. All right. So we have the mean daily temperature of San Francisco is 65 degrees Fahrenheit, and the standard deviation is 8 degrees. On one day, the high temperature is 49 degrees. What is the temperature in standard units? That's another way of saying z-score. And then assuming the empirical rule applies, does this seem unusual? Give you a chance to write that down. So mean 65 degrees, standard deviation is 8 degrees. The data value in question is 49 degrees. That's the data we're looking at. Then 49 minus 65 over 8 will be how we would calculate the z-score. So that's negative 16 over 8, which would be negative 2 as a z-score. All right. According to the empirical rule, 95% of the data is between -2 and 2 standard units. So that means this would be considered an unusually cold day. And so the way we can look at it, sum it up, is that 2, okay, 2 or greater or -2 would be considered unusual. And normal is in between 2 and -2 standard deviations. If I hold on to red and purple up there. Questions, everybody good? Everybody holding on to it. All right. So percentiles, the K percentile of a set of data is a value such that K% of the observations are less than or equal to the value. Kth percentile is denoted by P sub K. All right, so Jennifer just received the results of her SAT exam. Her SAT math score of 600 is in the 74th percentile. What does this mean? All right. So 74% of the people who took the exam scored 600 or less, and then 26% scored better, and the 26% comes from, 100 minus the 74. Those are all the other people. So they scored better than 600. Questions, questions, questions. And I believe, yep, that's it for 5.2. So for those who may have came in a little later, I was telling the class that I was only going to do 5.2 today to stay in the same track of my last class, trying to keep these two classes together. I had a dentist appointment that I had to leave their class early for, so we only did 5.2. So next class we'll do 5.3 and get into chapter 6 as well. Also, don't know if I mentioned it in this class or not, maybe I already did, but the week of the 17th, I will not be here. So I'll probably create a video. I'm not going to create any more assignments. You guys have the math lab to do. We'll just probably do at least one video as a lecture to talk about, a few things, and that'll be it for the week. But, I got to do something for the week and everything like that. But we will not have class, at our regularly scheduled time the week of the 17th. All right, all right. Questions, concerns, comments about anything? Make sure we're good. Yep, most definitely. So I have somebody that wants to stay back and talk to me after class. So is anybody else have any other class stuff before I close out? Is everybody good? All right. So you guys have a great weekend. Be safe. Watch the weather. Stay dry. And I will definitely see you guys next class. Have a good one. Thanks for just saying. Take care.